Hello, once again, wherever you are in the world. Good morning, good afternoon, good night. I'm Felipe Hoffa, Snowflake developer advocate, and we are live today with three very special guests. We're going to talk about what OM1 is doing with data, with the help of Hex, and with the help of my friend at Snowflake, Susan David, Senior Solutions Engineer, and representing Hex, Armin Efendic, and representing OM1, Zach Bryant. And representing yourself, say hi. We are monitoring the chat. We are getting the live questions. So say hi, say where you are today. I'm in sunny California, starting the day. How are you doing, Zach?
Doing great. Thanks for having me on board. I'm super excited to show off some cool tech, talk about how Hex and Snowflake really supercharges our ability to do data and analytics here at OM1 and just kind of dive right in, do some
Yes,
cool demos.
you have a super exciting demo, and OM1 is super exciting too. So I'll ask you in a second what is OM1, but let me welcome Armin too. How are you doing, Armin?
Good, good. Thanks for having me again. Really excited about this one.
Yes, I'm excited also about what questions people will have about Hex for us. And Susan joining us for the first time on this live stream, but she's representing Snowflake and she knows a lot about how all of this works. How are you doing, Susan?
I'm doing great, coming to you from Austin, Texas today.
Austin, Texas. I like it. What are you excited about in this episode? I know you know a lot about what they are going to show off.
Yeah, I'm really excited for everybody to get to see how OM1 is solving some of these business challenges, kind of making a self-service application using Hex. And folks will go away with a link to a project where they can take a look at how this was built. So quite excited to see what we have going today.
Yes, as a solutions engineer at Snowflake, you've been working with Hex for a long time.
That's right. Yeah, I support our partners like Hex and help them, build out their integrations and basically work together to solve challenges for customers. So excited to be here with Armin. We spend a lot of time together, so this is fun.
Yes, and we are all both everyone here is going to learn from Zach today. I don't see many live chats right now. I see that people are online. Sometimes LinkedIn is not good at sending me what people are writing. So if LinkedIn is not working, you can always jump to the YouTube live stream and send us messages there. So let's start with Zach. What do you
Yeah,
have for us today?
yeah. Let's jump right in it. Can you throw up the slide deck on screen?
Yes, you have some beautiful slides
All right.
to talk about Hex,
Yep.
OM1, and Snowflake, how to
That's
work with healthcare data. That is exciting.
Yeah, that's absolutely right. So, a couple things. My name is Zach Bryant. I'm Associate Director of Data Analytics here at OM1, and we're going to be presenting a case study for how we're using Hex and Snowflake to build data applications that turn business users into clinical data engineers. But before I get into that, I just want to give you a little bit of background of who is OM1, where we're coming from, and what we're looking to do, right? So we're essentially a team of scientists, clinicians, data practitioners, engineers, and technologists looking to create a new standard for health outcomes data. And we do this by leveraging two main technologies, right? We leverage big clinical data to build these really large clinical databases, and then AI to better understand and predict patient outcomes. And I'll kind of show off what that means in a couple ways. So what we really look to do is provide end-to-end real-world evidence and real-world data solutions from bench to bedside. And that all starts with partnering with health systems to aggregate data from healthcare systems, from insurers, from disparate sources across the United States, and creating this very harmonized 360-degree view of patients' anonymized data. We have an engine that processes all of that data and then puts it into a real world data cloud that is able to be sliced into chunks that are these research ready data sets. Once those research ready data sets are made, we have an internal set of researchers and clinicians that help do research on that data to better understand patient needs, unmet needs in the healthcare system, to better understand opportunities for medications to be used in better ways. We build that into automated registries that can even be used for regulatory grade applications, doing submissions to the FDAs to get new drugs and new devices on the market to address patient needs that weren't able to be done through traditional clinical trials. And then we also deliver those insights back to the patient. So you can imagine a world where you're a patient coming in and seeing your physician to get a total knee replacement. We're able to use our technology Phenome to look across the entire 360-degree view of you as a patient, to look at all of these patients that look like you across a bunch of disparate signals, and really understand, okay, in the real world, there's a bunch of other patients that look just like you, and they had these types of outcomes associated to a knee replacement. Maybe 60% of them improved, and 10% of them had some sort of surgical complication. We're really able to deliver that back to the point of care to help the clinicians make better decisions for patients and improve patients' outcomes. So
it's amazing how healthcare can improve with this kind of insight. So thank you. Please.
Yeah. So the entire business is taking all this data, engineering it all together, deriving insights onto that, and delivering it back to our partners. In a similar way, we do that internally as well. To generalize this presentation to non-healthcare audiences, I've taken a case where we've been able to pull information together, deliver it back to our internal customers, and really build applications, data applications that allow a normal business user to become a clinical data engineer. This is a problem that I've seen across all of my different companies that I've been at. And that's, how do you solve problems where the data needs to be managed by the business stakeholder? In a typical analytics pipeline, this is a mock-up of what it mostly looks like here at OM1, and it's probably going to look familiar to you. You have some sort of external system. You use an ELT tool to pull that down into some sort of raw data source. You have some analytical models in DBT that take that raw data and turn it into analytical concepts that you care about. And then you serve that up through some sort of reporting framework or BI tool. We use Hex to deliver that to our end users. And this approach works really, really well if the requirements are well defined, if the data updates aren't infrequent or they don't need to be managed by the end users, and that if the data just needs to be reported out to the end users.
And of course, life is always super simple like that.
Exactly. So I would say that, most of our reporting needs to fall into that bucket, but when they don't fall into that bucket, they really don't fall into that bucket. So an example where this really broke down for us is we provide a standard set of reports to our sales and marketing teams. We offer data. That's one of our core products, our data products. And we need our salespeople and our marketing teams to be able to talk about what is in that data, characterize that data. So we have a number of DBT models that automatically get executed every time the data gets updated, and it flows down into downstream reporting. We call these counts sales counts because they're counts that characterize our data, and we provide them to our sales team. Not a very innovative name. And these counts help our sales and marketing folks better understand both what kind of questions are the customers likely to be asking about a data set, as well as answer those questions directly. So it might look like, for our heart failure data set, how many patients are on an anticoagulant, which is a common medication that patients with heart failure will be taking. Or there's a new drug that just hit the market in psoriasis, how many patients are on that new drug? Or often we find our customers are coming to us with a very specific research question. They might have a major disease of interest, like major depressive disorder, but they want to find patients that have some sort of additional condition like anxiety or PTSD or OCD or some sort of other concomitant illness, and they want to do research on that. So they're always asking these questions of the data, and we provide reporting the best that we can to our marketing team so they can answer these questions rapidly. The main problem is that healthcare is a very dynamic field. New practice guidelines emerge, new medications are constantly coming out, new trends appear. You can see this if you're following the healthcare scene. We have these GLP-1 agonists for obesity and overweightness that are just taking the world by storm. Everybody's asking about them. They're wondering about it in every condition, not just weight loss or diabetes. So these things can change very rapidly. And when they need to change very rapidly, that's when our traditional pipelines tend to not work so well. So here's a view into a particular scenario that we'd find ourselves into. A sales team member would hear a new drug's come out on the market. A customer might ask for it, and they said, hey, last quarter, this new drug came out for psoriasis. How many patients do we have in our data set that's on it? I don't see it in our sales material or in our reporting. And they'd ask marketing this because marketing creates the sales collateral. Marketing would turn around and go, okay, product team. Why isn't this product, this new drug being reported out on product X? And the product team would be like, oh, well, it's because it's new. We need to add that. Let's talk to our data team and get that added. So one ticket to the product team would turn into a second ticket to the data team. That data team would then need to work with product to really define the request. Sometimes we'd have to pull in a third team that's more clinically oriented. So that's a third ticket, and really kind of work in that cycle to really understand the requirements of the ticket even before any code gets written. Eventually, an analytics engineer would go in and make a bunch of updates to a seed file that would feed into a DBT model or a series of DBT models that would then go and count the things that needed to be counted. And a fourth ticket would occur to the data engineering team to do a PR review and actually merge that into the pipeline. The pipeline would be reran. The data would land in the data store, would get served up to the business users, and you think you could plant your flag in the ground and say, victory, we are done. But they look at it and they go, well, now that I've seen it, or now that I've talked to more customers, we want to actually split out the counts. It doesn't matter if I don't need to know how many patients are on that particular drug. I need to know how many patients are on the oral formulation of the drug or the injectable or infusion formulation of the drug. And then, we'd start all over again. And you'd go through this cycle many times over, sometimes frequently, which causes a lot of friction in the system. And what ends up happening is people just stop asking questions, right? Really, the salesperson and the marketing folks, they know what the interest is. They know what they want to have reported out on. So let's empower them to do that, right? So we're going to kind of move into more of the architecture conversation now. So we see that diagram before, and that amounts to what is essentially a really long game of telephone, right? It's time consuming. Your signal degrades as you move through that pipeline, and maybe you're getting them the count that they need, maybe you're not. They know what they want. They just can't articulate it into the database or into the data structures. So what were the main blockers for us to be able to empower them to manage their own library of accounts? Well, first off, it's the data is kind of too large to just set a general framework for querying around it. A lot of BI tools, you can say, okay, I'm going to drag all my facts and dimensions in, and I can send a query over. You can't do that if you're working in a real-world data cloud that has 330 million patient lives and hundreds of billions of encounters. It's just too much to compute at one point in time. You request your count, and your salesperson would get bored waiting, and they move on to greener pastures, right? Simultaneously, you might say, oh, I'm going to go and pre-calculate all that, right? I can save that time. I'm going to do it every night, but you can imagine that if you have 13 data sets and 100 potential variables of interest plus 100 variables of interest in another area, that you get this kind of this Cambrian or this Cartesian explosion of potential contexts in which to count the count, and it just becomes you can't pre-calculate all counts in all contexts. Lastly, you still have to go through this data engineering pipeline to come in and add a new thing. Most BI tools are read-only. You get the information, you can't interact with it. You can't say, oh, I'd like to adjust this lever, or I want to add this component, and have it just automatically update inside the reporting. Lastly, CSV mapping files are kind of a standard of DBT. They work really well if you need 10 records to be mapped, or maybe add a couple dimensions, or add a few items that you want to adjust inside the mapping file. But once you get up to thousands of records, it's really easy to make a mistake, to misspell something in one file compared to another file, to add some white space in that file, or to just forget to add it all together. So it was just this very difficult process of managing everything through CSVs and through seed files. This is where Hex really comes in. With its native Snowflake integrations, seamless support for SQL, Python, and Snowpark, and its app building capabilities really saved the day for us. Finally, we could write an app that was focused on allowing the end user to manage their data in a read and write fashion.
Yeah, I love all of those keywords, and also Armin is going to explain us a little more about Hex in a second, but let's look at the architecture.
Yeah.
And then we can go deeper into what Hex is doing here.
Yeah, so we'll get into the demo in just a second, but to give you a little bit of a background, so we have some reports in Hex that our end users come in and they can very quickly see, okay, for a particular data set I care about, what are all the counts that I need to know? That is connected in with this new UI-based web application, all built in Hex, where they can come in and they can start managing those counts. If they need to add a new medication that they need to count or a new comorbidity that they want to look at, they can do that in the UI web app. And that UI web app sits right on top of Snowflake. They're sitting right on top of each other. You can read to it, you can write from it, and it just uses a Python framework. You can do this using normal Python or Snowpark to read and write to that application without needing any specialized APIs. You don't need any developers that know React. You can build this up very quickly just as a data professional who knows a little bit of SQL, a little bit of Python, and a bunch of UI features. Those tables get built into the database. The DBT model reads those in real time. It's a living, breathing seed data that tells those models how to execute and in what context to execute. And it drops that into the data store. In our example here, we don't actually have a trigger to run the DBT models, but it'd be pretty straightforward to add a button into this web app that says run my models, and it triggers a Lambda function or an API to automatically run, if that's in DBT Cloud or hosted somewhere, those DBT models to be executed. So you have this fully self-contained loop where you don't need a data engineer, you don't need an analytics engineer in the loop. You just have the underlying infrastructure, and the end users can manage it all themselves. So if they need to add a new count, it'll just flow through the system, end up back in the report. And in our case, we have downstream sales and marketing collateral, as well as other web applications that take advantage of that.
Yeah, the magic line for me, if we can go back to the previous slide, the magic line for me here is when you say the business user dictates what they care about in the UI, and the rest happens automatically. Exactly. I can't wait to see the demo of this.
Yeah, exactly. So before we dive in, just wanted to show a little bit of what does that look like under the hood. So we have these master data dimensions and mappings. So an end user comes in, they can declare a category. So they might say, I have a medication called warfarin. That's an anticoagulant. That's a common anticoagulant. And I need a count of it. So I'm going to say, this is a medication. The model knows to go run the medication models to go and build that. They're giving it some sort of grouping category, anticoagulant, so I can see all my other anticoagulants together. And then warfarin, that's the thing I want to count, right? And then the system provides a little bit of extra context to it of saying, I want to do that warfarin count inside of my heart failure data set. I care about it for heart failure. I don't care about it for the other data sets like psoriasis because those things have nothing to do with each other. And then lastly, you define some mappings. You say, when I say warfarin, I actually mean these things. Warfarin comes in a 5 milligram tablet, a 7.5 milligram tablet, and a 10 milligram tablet. And there's some codes in the database that represent that. So I'm saying these three things are what I want to count. In our case, this could be a list of potentially hundreds of codes. So we have an abstraction layer around here that makes it really easy to not have to manually choose all these things. But for your purposes, you might have just a basic mapping system that the end user declares. So let's
quick question for you. Before we jump in, traditionally, an end user would have to then be creating tickets and either talking to you or the product team or someone else and basically asking this exact same question of saying how much warfarin is used for heart disease cases.
Exactly.
Okay.
Yeah. And now we've automated all that. All they have to do, they don't even have to submit a ticket. They just know that I need to understand warfarin. Here's my inputs. And then the model takes care of the rest of it, right? Gives them back a consistent, standardized, governed answer because we have all of our business logic under the hood of how all those things are calculated. And they're just telling us, what do I care about? And in what context do I care about it? And the rest happens automatically.
I'm glad that we're jumping into the demo now, but let me say a quick hi to our friends on LinkedIn from New York, in the Bay Area, Atlanta, Philly, Concon, that's in Chile, my country, India, Connecticut, more India, and also our friends on YouTube, Code with Anshu and me. Yes, we are live and they're watching. We all want to see this demo in action.
All right, cool. So let me go ahead and move my screen over and take us over back to the app itself. So those aren't familiar with Hex. Hex is a data analysis platform that makes writing notebooks and publishing apps super, super easy. So in here, what we've done is we've built a notebook, just kind of like you would imagine a standard. Drawing a blank on the name.
Jupyter
notebook,
is
right?
good.
Yep. But you can add so much more extensibility to it, right? So under the hood here is a bunch of SQL, a bunch of Python, and some UI components to pull this all together. So on the homepage,
can I call two things out when looking at this? This is OM1's mapping manager. I see that it's open source, so it has been published, and it was published 2 days ago by Armin. So I see a lot of collaboration here.
That's correct, yes. So we're open sourcing this project. It's not going to be connected to the underlying databases or anything along those lines. So you'll have to provide your own data, but all the code will be here, and you're able to open source and use it for whatever purposes you like under the MIT license. So we're big believers in open sourcing here. This isn't a business critical technology by any means. It's a common problem that a lot of people face across a lot of different businesses. And it's great to show an example of how you can use this technology to build these really lightweight data apps that really empower business users to do things that they couldn't otherwise do. So we have a whole README file that you can look at here. But essentially, here's what the workflow is. I'm a salesperson, and I'm looking to characterize some blood pressure medications inside my heart failure data set. What I can come in is say, okay, well, let me know what kind of things I'm counting inside of my data sets. I can come in here and look at psoriasis for an example, and it will go in, make a call to the database, return all of my mappings from my psoriasis data set, and give me a sense of what are the things that are currently in that database. The query might be running a little slow since we're streaming, but usually it's pretty quick. So I can see here I'm looking at, in psoriasis, I'm measuring how many patients have anxiety, how many patients have obesity, and a bunch of drugs of interest, right? I can further see, how am I mapping those drugs of interest? So I can come in here and maybe I want to look at vitamin D analogs, right? I can come in and look and see, okay, there's these 4 medications that I call a vitamin D analog, and I've managed that mapping inside of here. This model's going to automatically do what I need it to do and return that count back to me in my reporting application, right? So let's say I want to add something new, right? So I'm going to be looking at the heart failure registry. I can see right now that the heart failure registry is relatively new. I only have 2 mappings in there right now, and I want to add to it, right? So I'm going to come over to my categories tab. This is where I define the thing I want measured. So I'm going to say I'm going to add some blood pressure medications. So I'm going to type in blood pressure medication here, but it's not a disease. So I'm going to go and change that to medication, and I can give it some sort of category that I might want included in it. So I'm going to put it under this other medications of interest category. If I wanted to do something totally myself, I have this manual entry field here where I could, type some stuff in and then add a bunch of records in bulk and, do whatever I needed to do if I wanted to do things all at once. We recommend doing this nice lightweight UI approach because it makes it really easy to add in new medications without worrying about the underlying data structures or making sure that you type in medication correctly. You just use some drop downs and you can get to what you want. So here, I can see, hey, I have a medication, I have blood pressure, I can click this insert selected records. This insert selected records is going to go in, it's going to do some validation checks to make sure that this is not a duplicate record, that it can be entered in, that everything's formatted correctly, and go in and write into my database, hey, you have this new blood pressure record, a blood pressure medication record that is now going to be counted. I need to tell it what I want to count it for, though. I don't care about blood pressure medications in psoriasis. I care about it in heart failure, and I can come in and type in, my new sales count that I just added. Say, hey, I got my blood pressure medication. I want to add it to my heart failure registry. I can insert that selected record into my database. It'll go in, double check everything, go in and insert the item, and then I can come in and add some mappings to it. So when I say blood pressure medications, I mean a couple things. So I come in here, it's pre-populated with a bunch of stuff, but let me just go ahead and add. I don't want to do all. Let's do lisinopril, let's do losartan, let's do labetalol. Those are 3 blood pressure medications. Learned something new today. Certainly not an exhaustive list, but shows the example, and it goes and looks up the codes that are associated to it. I didn't need to go and know that Listinapro was coded as code 29 in the database. Just does all that for me, and I can go and click insert selected records. And once that's done, looks like we had some sort of timeout error. Take my word for it. It'll the demigods always do something wrong. It'll write it into the database, and you'll be able to view it inside of your reports just like that. So that's kind of that workflow. Is you write on a step-by-step basis, you write those into the database. I can come back over in here, and you go back to my view. I can refresh my data, and I'll see my blood pressure mapping in here.
What's surprising for me here is you described it as a notebook at first, like that's how this all starts, but it's so much more. It's an application that also you can open source, and Hex is helping you build this. So I want Armin to comment on this, but first I have a question from Francis Xavier, and he wants to know, how is this model continuously learning? Is it data static, or is the model learning in some ways?
No, so that. Yeah, no, this is your bread and butter logical model. So there's a bunch of underlying business logic and heuristics and DBT models that sit behind the hood. And when you go and you say, I want to count something, you're basically sending inputs into that model. It goes in and does all of the logical processing and returns back a number for you.
Nice. And Armin, what can you say about Hex? How is it being utilized here?
Yeah, I'm super excited when I come across use cases like this one from Zach and OM1. What's really interesting is because Hex can really act as kind of a blank canvas for any and all data work. You can bring in less technical users to do even some Excel type stuff, right? In OM1's case, they're actually making an app that allows business users to basically mimic or be their own data engineers for their own ad hoc use cases, right? Instead of having to build out all these metrics or a very detailed semantic layer, to Zach's point, where it's like maybe 1,000 different types of counts. You don't want to be calculating that every single night, but you still need to give that ability to end users. So instead of them having to go in and create all of these SQL queries or no Python, it's nice to kind of have a UI layer where you can go in and say, okay, here's just a GUI element to creating these counts. And then we can have those referenced downstream in whatever sort of reporting tool you may want. It could be Hex, it could be another tool, it could be a BI report if that's what you wanted. You can bring that into slides. So it's really, really cool when I see use cases like this, where it's not just the tried and true, data scientist that is SQL or Python savvy coming into Hex. And we're definitely pushing that, and kind of our ethos at Hex is really saying, hey, we know we have a really, really high ceiling for these technical users that love the product, but we also want to cater to a lower floor. And we're really pushing strong on making sure that that floor is as low as possible, so we can bring in less technical folks, or even with the likes of like an app builder like this, we can bring in pure business users to still get so much value out of Hex. Move from a less traditional notebook environment. We're trying to redefine the use cases that you can do with notebooks today.
Yeah, and just looking at the notebook view, this is just a simple notebook environment. I'm importing some libraries. I'm using UI functions, just out of the box UI buttons. I can come in and add a cell, adding in input buttons, and then just doing some basic, SQL, and then executing that. And I package that all up in this little app builder view, and I publish it up into what the end users see. So we extract all that technical detail away from them, and we just provide them with a very easy UI framework without necessarily needing to write any complicated rack components. Most of the Python you'll find in here is extremely straightforward, and we're able to build something very, very quickly with very limited engineering resources, and deploy these things in a very agile way.
And if you go back to the other tab, you can even see at the top right of the screen, you can see both our icons. So this is a little bit of a peek of how we actually made this publicly available. As Zach and I both worked on this project. So we went in, we actually stripped down and anonymized some of the data. We made sure that it all works and functions if you were to hook this up with your own Snowflake instance and try it out. And we were able to real-time collaborate. So I can leave comments in there. I can ask Zach, hey, is this actually looking right to what you guys are doing? How do we anonymize this, right? And we can do that almost like a Google Sheet or a Google Drive doc, where you can go in and have commenting and real-time collaboration. So both him and I can work on the project at the same time without clashing.
So here you can see both of us in there. I can come in and, at mention Armin, say, hey, can you take a look at this, right? There's a whole review process. It's a really nice way to do app development. You can use people with different capabilities. It's a really enjoyable way to make data and accelerate the ability for us to go and deploy these solutions to the end user.
And even share with the world. Susan, as someone that gets to work at Snowflake with Hex and see this deployed now with customers, what are your reaction thoughts?
Yeah, I think this is so fantastic. And I think the thing to really keep in mind here, we might think of a traditional BI application where you can kind of slice and dice and do that kind of categories. But what's happening under the hood, right, that Zach mentioned with the Hex integration is this is then writing back right to those data mappings. And so kind of creating a new record so that the next time someone has a question about these blood pressure medications, that's already in there, right? So that's very different than someone kind of creating a one-off dashboard that just, lives on their own, kind of local instance. In this case, they're able to kind of take that business logic. In this case, it's what are the customers asking for? Building that back end so that there is this kind of continuous improvement of that mapping and that underlying data model. And that's really achieved by the integration that we have with Hex. So it's very cool, and an end user, they may not even be aware, right, that it's kind of Snowflake that's driving this. And that's amazing, right? So that business user, they just see the data working and getting the insights that they need, which is very cool.
Yeah. And you can see it right here. This new blood pressure category has been added directly to that database. So it's the user that's defining the context, the things that they care about, and the rest is handled automatically. We have our DBT models, they run on a regular cadence. It's gonna pull that in on its next run, report that out to the business user in their operational dashboard. And really take away all of the tickets, all of the technical complexity. It makes them able to just seamlessly express the concepts they care about and have that translate into reporting that matters to them, right?
Yes. I have a question from Rahul that's a little skeptic. But before asking the question, I want to call out that I can see your bookmarks and I love the world where you live in, Zach. So you play with Okta, of course, that's how we authenticate. We play with ChatGPT, with Google. You do a lot with Power BI. Of course, Hex. Data.world is your catalog, but I also see ontology is a very important topic in your life. Snowflake, GitHub, Jira, Confluence, Airbyte, DBT. These are all the tech world we live in. So, but you also work with all of your users is inside OM1 that don't know these technologies and don't know them well. They just want results. So in that context, I want to ask you this question from Rahul Kumar, who is a data warehousing expert. So his skeptic question is, how much of coding is needed by business users to be able to do these custom queries? Counts. Most of the time, business users are more comfortable doing just SQL queries, and in few occasions, they do hands-on in data visualization tools. Not so sure if it will be simple and straightforward for them to work on their own. What would you tell?
Yeah, so what we're really doing here is we're providing them a framework for expressing their concepts and doing most of the technical heavy lifting for them. For users that are very comfortable writing SQL, that can build these DBT models, that can self-service their own needs, that's definitely the right framework for them, right? Coincidentally, we have found that once you have some sort of standardized framework, you tend to get some non-technical users in here using this as well. I could go in and I could write some DDL to, add these things to the database directly. I could go in and manually write some DBT models that add these things through. I can write a CSV file that adds in additional records, pushes it into our database, pulls the PR, merges it in, and do all that myself. But what we find is if you create a good abstraction on it, it's going to be quicker and easier to do via the abstraction. I actually come in here and just using those 3 steps, go and add, if I need to add a count myself, because I wear both the clinical hat as well as the technical hat. I just do it in here, even though I could do it in the database. So what we find is if you provide a good framework, good layers of abstraction, they'll use the application rather than having to hunt and peck for technical solutions themselves. Yeah.
And I think,
then
right,
you
like
have
Zach, you talked through like what was created, what was needed to create the app versus what a business user needs to do. This is it, right? For what a business user, they're just typing this in, free text, using those drop downs. Like there's not even SQL, right?
That's correct. Exactly. Now, there is this big group of users that don't know SQL, right? They're clinicians. They don't have any technical foundation. They have to use a tool like this. That makes up, or our marketing people or salespeople. They're not SQL proficient. A lot of times they're just barely proficient on the BI tools where they know how to do the read functionalities, but they really can't do the more advanced stuff, right? So providing them a simple abstraction provides a lot of value, in my opinion.
Yeah, I love my tech because I've been a fan for years of, I'll give my business users some sample SQL queries and they will use them and figure out what changes to make to get what data they want out of the database. But then that might work, but then I'm not learning from them. What results are they extracting? Are they doing the right SQL queries? Are we collaborating and building the right metrics together? So for me, it's really cool to see how we bring the knowledge that they're extracting back to our common platform and reviewing it between us.
Yeah, and I do want to be clear, this doesn't totally remove the data engineer or the analytics engineer, but instead refocuses them. Instead of managing these seed files, taking tickets every single day, it allows them to think of what are analytical models I can develop and what are changes I can make to the underlying model that makes generating more diverse types of counts, more nuanced types of counts, better counts that better represent the concepts that the businesses are asking for, instead of managing kind of this more operational workload, right?
Nice. It's almost time to close, but before we close with your thoughts, with your action items. So, Zach, what would you like people to do next?
Yeah, so just wanted to give some shout outs here. You can follow us on our LinkedIn page. We have our careers page located here in the slide deck. You can probably post this alongside with some of the notebook information. And then we also have you can find us on Twitter /X. And then I just want
to have to say, even when we turn off the live stream, all our comments will be live. Please leave more questions for us. Zach, Armin, Susan can go back to LinkedIn and interact with all of you. Like we're going to share these URLs. This is OM1, real world data and AI for medical research and personalized.
So you can find us on OM1.com. And then just wanted to give some shout outs. Thanks, Snowflake, for hosting. This has been a super great time. Thanks, Armin, for working with us and helping us open source this effort. And then just want to give a shout out to one of my analytics engineers, Bryce Beatty. He helped write most of the app. So big shout out there.
Thank you so much, Bryce. Armin, what are your closing words?
Yeah, so thanks again for having us. I'm super excited. Even when I see customer use cases like this that are maybe off the beaten path, but drive a lot of value. We'll be passing along the actual project, the open source version of it. So if you did want to take it out for a spin and hook up your own Snowflake instance with your own data, I'll drop that in the chat. Any other questions, feel free to reach out to myself. Zach, I'm sure we'll be more than happy to help as well, and Susan. So thanks again for having us.
Oh, thank you for coming. I love seeing how things get put in the real world. Well, my life will be better thanks to OM1 and all of the data we are moving around. Susan, your closing thoughts?
Yeah, I think with Armin, go get your hands on this app. These guys have open sourced it for all of us. And, we talked through a really clinical use case today, right? But business users have the need to update, use an application. This is really moving beyond notebooks to having, putting these data applications in the hands of your end users. So go around there and play with it and, tag us and let us know what you build, because we're excited to see.
Yeah, like you could say we have a particular customer, we have a particular business domain, and in the data that's represented 5 different ways, right? You can apply this to any time where you're doing mappings, you're defining singular concepts for things and needing the rest to happen automatically, right? So the types of applications of this problem extend much beyond healthcare.
Yes. So thanks so much for this. We are all data people. Let's use data to make a better world, and let's help other people, our teammates that don't know SQL, to do better things with SQL and with data. And those that know SQL, even then, we can collaborate and find solutions together with the right tools. So this was awesome. Thank you, everyone. Thank you, everyone, for watching. The next time you're here, Susan, I will ask you about your experience with Python or wherever the snakes are behind you. I see some snaky things. But yes, thank you, everyone. I think it's time to let the bear dance for us.
Thanks,
Good night.
everyone.
Thank you.